right, so we're continuing talking about factoring. So far we've learned factor by grouping. Well, first we learned greatest common factor, which is what we always look for first. Then we learned factor by grouping, where our prompt to try factor by grouping is if we have 4 terms. Now we're going to get into, in 6.2, a particular type of trinomial. So in particular, we are going to be focusing on trinomials where we have the form an x squared, an x term, and a constant. What I really want to emphasize here is 6.2 is about factoring trinomials of this type where the lead coefficient is 1. So we're factoring a 1x squared, an x term, and a constant. So just like factoring by greatest common factor is kind of an undistributing process, we look at what we do multiplying and kind of apply it in reverse. That's what I want us to think about here initially. So what happens when I multiply out x plus 2 times x minus 8? So the x times the x is going to give us the x squared. The x times the minus 8, so that's going to give us this minus 8x. And then the x times the 2 times the x, that is giving us this plus 2x. And then the 8 times the minus 2, that last term there, is giving us that minus 16. So that comes from, I know this is going to look a little weird right now, taking the 2 times the minus 8. And I just noticed I left off my x squared on that first term. So we end up with x squared minus 8x, and then we have the plus 2x, and then the last term comes from the 2 times the minus 8. So of course when we combine our like terms, we end up with looking at the x squared plus, and then it's the operation of those coefficients of the x when we combine like terms. We add up those coefficients, that's what we do with like terms. Those give us the coefficient of the x, and the last term came from the product of those two numbers. So I know, like, you would never write it out this way, right? Like you would just say, you would just immediately go to, okay, this is just going to be x squared minus 6x and then minus 16. But this is what I want you to observe, is that this middle, this x to the first power term, this was the sum of those two numbers, the 2 and the minus 8. And the last term came from the product of those two numbers, the 2 and the negative 8. So every time I'm talking about those two numbers, when we work backwards, these are going to be the two numbers that we have to work to find. And it is the sum of those two numbers that's the coefficient of the middle term, and the product of those two numbers that is the last term. So let's just write this out in general for any m and n. So again, the m and the n themselves could be positive or negative. So what happens when we multiply this out? We have the x times the x is the x squared. So notice that's what's giving us that 1x squared that is really the focus of this section. And then we have the plus mx. And then when we multiply again with the outer terms there, we have the plus n times the x. And then the last term comes from the m times the n. So again, what we want to observe is when we would combine our like terms, we would have that 1x squared. It would be the sum of the m and the n, including, those themselves could be positive or negatives. That sum becomes the coefficient of the x term. And then it is the product of the m times the n that is the last term. So again, in general, the sum of the numbers that we're looking for become the coefficient of the x term, and the product of those numbers is what is the last term. So this is going to be our factoring pattern. Now the whole idea is using this observation, these observations, and working backwards. So when we start with a trinomial of the form, again, notice this is of the form a 1x squared on that trinomial. So when we start with, oops, I don't want to confuse that with my MN color, the products. I'm going to put a big 1 here in black. Okay, so everything in this section is about factoring of the form 1x squared, and then plus the x term and plus the constant. So when we have something of that form, we know the only way to get back to the x squared is to start with the x and the x. So that is not going to be the issue. The issue, if you will, is coming up with the two numbers that we want, those two numbers in that second slot. And so in that situation, we need the numbers whose product is the last term is going to be the, well, actually, sorry. The product, it won't be written as an m times an n. The product is going to be right here. It's going to be whatever that last term is. So we are going to look for two numbers whose product is that c term, including its sign. So I'll put that little sign in front. And then whose sum is the coefficient of the x term. So the sum is going to be whatever that b is, again, including its sign. So that's how we figure out what numbers to fill in. All right, let's give this a go. Let's look at some examples. So number 1, suppose we have x squared minus 13x plus 40. All right, so it's definitely the trinomial of the form we're focusing on here today, which is the 1x squared. So let's observe that 1x squared, the x term, and the constant. So if it factors, it will start with an x and an x. I am going to need then two numbers that add up to or have a sum of that negative 13 and multiply to or have a product of the positive 40. So first I want you to think to yourself just in terms of how do you get a positive product and a negative sum? The only way that can happen is if both of these numbers are negative. That's the only way to get a positive product and a negative sum. And you just kind of have to go through factors. 2 and 40, no. 4 and 10, no. Hopefully, and you may need to use your calculator to run through some numbers if you're not so great with coming up with pairs of factors, but this will be an important skill. So the minus 5 and the minus 8. Now, the beauty of factoring in this chapter is you can always check that you have the right answer by multiplying those out and make sure that, and of course in this case, I get to x squared minus 13x plus 40. Perfect. That means I have the correct factorization there. X minus 5, x minus 8. Or x minus 8, x minus 5, because the multiplication is commutative. All right, number 2. Suppose we have x squared minus 7x minus 18. All right, so as we get started on this one, again, we're definitely of that form of the 1x squared, the x term, and the constant. So if this factors, first of all, let me back up. No GCF, right? We should always be looking for GCF first. We have not had a GCF here. So if this factors, just like the last time, the only way to get to the x squared on that first term, think about what we do when we're doing our check as we multiply the x times the x. That's the only way we can get to that x squared. So now we have to try to figure out what those numbers are. So this is our pattern. We're looking for two numbers that add up to, give us a sum of negative 7, and multiply or give us a product of negative 18. All right, well, a negative product has to mean opposite signs. So one positive, one negative. And sometimes, again, you're just going to have to run through some pairs. Maybe you're going to be thinking about 6 and -3 or 3 and -6. That multiplies to -18, but it doesn't sum to 7 or -7 rather. And so hopefully eventually you get to the -9 and the +2. So as I'm doing it, it just kind of feels like I'm pulling it out of thin air a little bit, but you just have to run through pairs of factors in your head that give you that -18 product and try to find the right ones that give you a -7 sum. Again, always a good idea to do the check. The reality is if you have satisfied the criteria of the appropriate sum and the appropriate product, you will have the right answer, but it's always a good idea to run that check. So this is definitely, it checks out. X minus 9 and x plus 2 is our correct factorization. All right, number 3, a couple more in this video. 2x squared minus 10x minus 28. So remember what I just started to say in number 2. We should always be looking for GCF first. And in fact, if you notice right now, so don't write this down, but that 2 that's in front of the x squared right there, that's not a 1. So it would not be okay right now to say, oh, I'm going to look for the sum of 10 and the product of -28. That would not be okay because we're not dealing with the pattern that involves the 1x squared, the x term, and the constant. We'll talk about how to handle it when it's not a 1x squared in the next section or two, but for right now, we still always want to start with GCF. So in this case, I can factor out a GCF of 2 from all 3 terms. So when I do, I'm going to have times the quantity of x squared minus 5x and minus 14. Now maybe that's all the factoring that I can do. But actually this one will factor further. But that first factoring out of the GCF, you always want to be on the lookout for that. All right, now in the set of parentheses, I do have that 1x squared, the x term, and the constant. So that is what will now allow me to think about just what's in the parentheses, looking for the sum of the -5 and the product of the -14. So if this trinomial factors, it will factor, again, with an x and an x. Negative product, we got to be thinking opposite signs. And probably the first 2 that jump at us, really the only 2 other than 14 and 1, and obviously that won't differ by 5, is 7 and 2. Now we got to get to the negative sum of -5 rather, so the -7 with the +2. That gets me to the -5. Again, you can multiply it out and check it. It will work. And the last thing I want to mention on this one is anytime you have factored out a GCF in the first step, even if it's just a little unassuming constant, it is part of the complete factorization. So you need to get that GCF carried along in your final answer. All right, one last one here. Number 4, suppose we have -x squared plus 2x and a -1. So again, what I want you to notice, don't write this down for right now, but this is not just 1. And so that's why it will not be okay to look for 2 numbers that give us a product of -1 and a sum of 2, because we don't have a 1x squared. So that means our only hope right now is a GCF. And, you know, there's not really much of a number per se to factor out, but I can factor out that which is causing me to not have a 1x squared, which is the -1. So it is very common practice when you're factoring out GCFs, if the leading term, that term of highest degree, is negative, we tend to factor out a negative with GCFs in general, or in this case, it's just a -1. So we would have -1 times the x squared Negative 1 times minus 2x would get us back to plus 2x. And negative 1 times plus 1 would get us back to minus 1. Now we have the all-important 1x squared that we need in order to apply our pattern of looking for two numbers that would give us, oops, I started to write the wrong thing, that would give us a sum of the negative 2 and the product of the positive 1. So in this case, again, if this factors, not everything will. If you can't find those two numbers that give you the appropriate product and the appropriate sum, then the polynomial doesn't factor, it would be prime. But in this case, we can do it. Again, a positive product and a negative sum has to mean both are negative. And in this case, the only way to multiply to 1 is 1 and 1. So negative 1 times negative 1 is positive 1 on that product, and negative 1 plus 1 does add to negative 2. Now again, remember what I said, any kind of GCF, including just this little negative 1, needs to be carried along in the final answer. And you could just write it as a negative in this case, or a negative 1. And that's okay. Probably a more succinct way to write this answer is this has that, it's that perfect square trinomial that factors into the same binomial times itself. So we could really write that as that x negative out in front, but the x minus 1 quantity squared. All right, so that's our basic trinomial with the lead coefficient of 1. When we come back next time, we're going to look at a couple of what I call common extensions of this trinomial. So that's what we'll look at next time.